Hi folks, we're going to take a look at page 175, number 18b, and in this question here they're asking us to solve this system of equations. So I notice here I've got two unknowns, two equations. The only difference from what we're used to is that this is not a system of linear equations. Okay, question is can we apply our methods for solving things like linear equations or systems of linear equations to solving this here. So we have elimination or substitution as our options, and I don't see any way to do an elimination given that I've got this sum here but I've got a product in the second equation. So I'm going to try to use a substitution. So question is which equation to use. I'm definitely going to go for equation 2, because if I try to isolate one of these variables, I'll have the square root of 1 minus x squared, say, if I'm isolating y. Much too complicated. I'll get something significantly simpler if I work with equation 2. Okay, so I would rather not work with a decimal here, work with a fraction, so change that to a half, and I'll choose to isolate y. So I'll divide x to the other side, so I have 1 over 2x. So now I can do what I normally would do with substitution, is substitute that into the other equation. So now we've got x squared plus, substituting y by 1 over 2x squared equals 1, and I end up with an equation and one unknown, which is what I was hoping for. And I notice that it happens to be a rational equation. So let's see how we can solve this. So first I'll clean this up. So x squared plus, this is going to be 1 over 4x squared. Remember, don't forget to square that 2 also, equals 1. And our method for solving a rational equation is to just start off by eliminating the denominators and turning this rational equation into a polynomial one. So the only denominator is 4x squared, so I'll multiply both sides of the equation by 4x squared. So here 4x squared times x squared, that's going to be 4x to the fourth. Here when I multiply the second one, the 4x squareds are just going to reduce, so I'm going to have plus 1, and then here 4x squared. Now I've got my polynomial equation, so how do we solve that? We bring everything to one side in order to get 0 on the other side. Okay. Now here I could have also specified that I've now turned it into a polynomial equation, but I still have that restriction from the first one. So I just specified that x definitely can't be equal to 0. So if that ends up being one of my answers, I have to eliminate it. So I look here and I see a quartic. Having said that, I do see a 3-term quartic. So as I often do, I'm going to think of this as x squared squared minus 4x squared plus 1, okay, and factor it as a regular trinomial. Now, hopefully you recognize this as a perfect square, but even if you don't, just go ahead and realize that these two terms have to be equal to 1, and what's going to help me get to negative 4? Well, if I split this up as 2x and 2x, and negative 2x minus another 2x gives me my minus 4, except it's not x, it's x squared now. All right, equal to 0. And now that I have it in factored form, I can solve for the answers. So since they're both the same, I just have to solve this once. 2x squared minus 1 equals 0. So 2x squared equals 1, x squared equals 1/2. And again, please remember when I'm taking the square root of both sides, okay, that I have to consider both the positive and negative square root. Okay, so I'm just going to clean this up a little bit. I'm going to write as plus or minus 1 over root 2. Okay, now you notice here that I'm not rationalizing the denominator. Well, technically that's what we should be doing. In this course here, I'm going to accept square roots in the denominator. Okay, so that'll be we tend to be a little less picky about that in this course, especially when we get to trig. So let's recap here. So step number 1 was to realize that we had a system of equations, and so that we could use one of our two methods, in this case here, substitution. I do exactly what I would have done in the past, just isolate one variable, substitute into the other equation, but in this case here I end up with a rational equation to solve, which I do by multiplying by the lowest common denominator and then solving the resulting polynomial equation. Okay, that's it for this one.